Okay, so good morning everyone. This will be the video guide for our lab work number 7, Excel. The topic is Data Analysis ToolPak for Excel, specifically for the statistical tests of t-test. So under t-test, there are 3 tests, paired t-test. We have t-test assuming equal variance and assuming unequal variance. And then later on, we will proceed with ANOVA, F-test. And then lastly, we have correlation and regression. Okay, so let's start. Okay, wait. Let me check. Okay. Oh, hello. There's somebody watching. Okay, so to start, we need to click file here, file, and then go to options. So sometimes it's hidden, but it's here, options. Okay, and then under options, go to add-ins. Oops. Okay, add-ins. And then you're going to click Analysis ToolPak. Analysis ToolPak, not the Analysis ToolPak-VBA, but just the Analysis ToolPak. So sometimes it's here in the inactive, especially if you did not activate yet the Analysis ToolPak. So just click here and then click Go, and then make sure that there is a check mark on the box under Analysis ToolPak. Then click OK. Okay, and then in your activity, so just follow the activity here. So I have posted it in your MS Teams. So if you follow the activity, you will see the data set. So you have the data set here. So in my case, I'll be using this data set here. Okay, so I'll just copy, and then paste it in the Excel file. Okay, so you will have something like this. But take note, the data is under one column. So we need to use text to column features of Excel. So we go to data and then just click text to columns. Then choose delimited. Next. Click next. And then take note, the separators or the delimiter is comma. So just click comma here. Then you will see that the data is separated already into different columns. So just click next and then finished. So you will have now your data set in this manner. So let's just adjust. Okay, so this is our data set. We have 40 rows or records in my case. So in your case, you have, I think it's also it's just 30. So in your activity, it's just 30. Okay, so let's rename the sheet as dataset. Okay, so let's do the first test. So let's try to create, what's the first test here? We create descriptive statistics. Okay, so to create descriptive statistics, so take note, just follow whatever is asked in the activity. In my case, I'll be using reaction time. So I'll be using this. So in milliseconds. So I'll just go to data. Then you will see now if it's activated, you will see the data analysis here. But if it's not yet activated, you need to go to options, add-ins, then activate the data analysis ToolPak. So I will click it here. Then I will go to descriptive statistics, this one. And I'll just click OK. So input range, so I'll start with the header itself, reaction time in milliseconds until the last part of the data. So 40, line 40, so 306. So group by columns, then I will check this one, labels in first column, and then okay, running. This is okay, new worksheet, and then I'll click summary statistics. Okay, and then okay. Okay, so you will have something like this. So this is already the summary statistics for our data set. So I'll rename this one as descriptive or DSC. Okay, so let's make this one 2 decimal places. This one. Okay, now this hashtag n-a. So remember, this is mode. It means that you have no mode. Okay, so let's add the variables, or rather the headers here. So mean is the measure. These are the different measures, or just a measure lang. Then we have the values here, and let's add interpretation. Okay, so for interpretation, we just need to interpret this one and this one, skewness. So remember, in kurtosis and skewness, so there are numbers, remember. So for kurtosis, we have mesocortic. Mesocortic is 3. We have, what's that, leptocortic. Leptocortic is less than 3. This one is equal to 3, or approximately equal to 3. And then, oops, I cannot put equal. I'll just this equal to 3 there. And then we have platycartic. Platycartic, it's opposite the eye. This is greater than 3, this is less than 3. Okay, so that's for kurtosis. For skewness, if it's 0 or approaching 0, it is normally distributed, diba? So bell shape, or just name, let's call it normal. If it's less than 0, so it means that the data is approaching to the left, so it's up to the left, yeah, so it's right. Then if it's greater than 0, it's left. Okay, so this will be our basis for the kurtosis and skewness. And of course, we already know mean. We already know the standard error is the margin of error, or some. Actually, this is your. This can be used as margin of error. Median. It's the middle value. So mode, in this case, we don't have mode, so no mode. Standard deviation, sample variance, kurtosis, so negative, so we have platycartic. This is platycartic. Then for here, negative, so less than 3 man. Then ang skewness, so take note, this is almost approaching 0. So when I say almost approaching 0, it's between negative 0.1 to 0.1. Oops. Why is it like this? Naka formula. Just put like that. Negative. Okay, so it means that this is actually normal. Okay, so let's just rename this one as descriptive stat. Descriptive statistics of reaction time. Let's just edit the format a bit. I will make this one bold, and then let's stop this one. Then this one also, I'll make this one bold. Okay, so we have now our descriptive statistics, or we can make this one a table na lang para there. Okay, so that's the first table. So again, this is just guide. You don't need to write this one. I am just typing this one as a guide. Okay, let me check. Okay, so next, let's say you are going to create, so the next one here is histogram. So histogram, let's say we want to create a histogram of the reaction time. So again, we just go to data analysis, then you will see here the histogram. So okay, so input range, so choose the same or whatever is asked. So always check whatever is asked in the lab work activity. So bin range, just leave that blank, just put labels here, and then never mind, just click this chart output so that we don't need to create a separate chart anymore. It will give us automatically the chart. So click OK. Okay, so it will give us this, so a new sheet with the histogram and of course the table. So here we have the table, we have the beans and the frequency. So let's just make the beans 2 decimal places. Okay, then for the histogram graph, so we can edit. Let's just remove this one. Okay, then we have click this one, then format data series. So remember, histogram, the gap of the boxes are there is no gap at all, so we need to decrease the gap. So it should look like this. Okay, so we have here the histogram of such reaction time. In ms, milliseconds. Let's just make this smaller because it's too big. There. Okay, so if we try to look at the data, so let's try to compare our answers here. So we said that the cortosis is platycortic. If you try to look at the data, it might not look like platycortic at all at first, but if you try to observe, diba, the bars are actually almost, what they call this, flat. It's flat. It's flat here. Naray na simang na usa. Okay, this part there is a missing data. So at the middle. Okay, so then we said that it's normal. Okay, now why is it normal? Because if you try to look at the data, this is actually approaching binomial distribution. So there are two normalities here. So it's actually normal. But again, we are not actually discussing binomial distribution, so we'll just say that normals here. So it might not be obvious at first, but it is. Okay, so that's it for histogram. So I'll just name this one as hist. Okay, so let me check. Am I still recording? Okay. So next, let's have ANOVA. Okay, so for ANOVA, ANOVA needs different groups. Okay, so let's say we want to test the weight, but in different groups. So we need to group our data first. So let's just select all the data. Okay, we don't need to create a table anymore. We can actually just, you can also create a table, but I would suggest not to create one because we need to separate certain columns, manggod. So I'll just use the sort and filter here. So I'll just click this one. This is sort and filter, then filter. Okay, and then I'll arrange the group from A to Z, and then I'll copy the group, column group until here, Control C, and here Control V, and then let's say again we're going to compare weight. So I'll copy the weight here, Control V. Okay, now we need to separate the data. So we have control and treatment. Okay, and then I'll just copy this until here. Copy. And then for treatment. Okay, then I can delete now this one. I'll just delete this one because I don't need it. So I only need this part here, this portion. So let's use ANOVA, single factor or one-way ANOVA. So click data analysis. So you will see here ANOVA single factor. So okay, so I'll just select this new table, this part here until this one. Okay, then group by columns, labels in first row, and make sure that your alpha is 0.05. This is the number that we are going to compare with our p-value. So 0.05. So just new worksheet. Okay, so you will have this. I'll name this one ANOVA. Okay, ANOVA single factor. Okay, so we have different interpretations here. We need to interpret the data. Factor for weight. This is weight in kg. Okay, so let's analyze the items here. So first, so we have the guide here. I will put the guide here. First, we need to compare the F value and the F critical. So if our F value is greater than our F critical, so sometimes the F value is known as the F statistic. Okay, so we have F crit. It means that we reject the null hypothesis. Otherwise, if it's opposite, what's the opposite of greater than? It's less than and equal to. So less than or equal to. So this is fail to reject. So again, do not say accept, it's fail to reject. Fail to reject. Okay, next, if we have p-values, of course. So if our p-value, I'll just type p-value is less than 0. So in our case, our alpha is always 0.05. So I'll just type 0.05. This is reject also. Reject null hypothesis. But if our p-value is greater than or equal to 0.05, so we fail to reject. Okay, that's we fail to reject. I'll just check if I am still recording. Okay, sige, so sorry. So this will be our guide. So now, how do we create the hypothesis? So for the null hypothesis, always remember that the null hypothesis is the status quo. So the status quo means they are all equal. So the groups are equal. Specifically the means of the groups. So there is no, let's just say there is no significant difference between the means of the groups. So that's a standard response for alternative hypothesis. So instead of saying there is a significant, remember when we use ANOVA, ANOVA is, you can use ANOVA for 2, but it's more applicable for 3. In my case, it just so happened now we only have 2 groups. So the better statistical method to use would be t-test. But again, I'm just showcasing how to use the ANOVA. So for this case lang na I use ANOVA ha. But it's not actually proper to use ANOVA if you have 2 groups. Better ang t-test. Okay, so in this case, we will say at least, alternative is at least one group has a significant difference in their means. Okay, so that will be our alternative. So let's try. So in your case, you're going to put the interpretation here. So let's just copy this null and alternative hypothesis, alternate hypothesis. I'll put here. So we have, there is no significant difference. So we'll just change something, a bit in the statement because this is specific. So what means, what groups is control and treatment. So there is no significant difference between the means of control and treatment groups. And then for the alternative hypothesis, let's just copy and paste here. So at least one group has significant difference in their means. So we're not sure if it's the control ba or it's the treatment, because that's the disadvantage of ANOVA. You cannot actually detect which has the difference. We just know that there is a difference. Okay, so that is for ANOVA. Okay, wait, we forgot the conclusion pa. So interpretation, we need the interpretation. So let's just analyze first the values. So we have our F value. F value is this. So let's just copy this one. And then our F critical is this 4.09817. So if we try to compare, it means our F value, the F statistic, is less than, diba, kay 0.04. This one is 4.09. So based on this, if it's less than So our interpretation is fail to reject. So let's put remarks here. Remarks. This is fail to reject. Oops, sorry. Fail to reject. So it means that the status quo wins. So there is no significant for F value. Okay, next let's have the p-value. So for the p-value, okay, p-value, our p-value is this 0.82. And remember, our alpha, we'll just name this one alpha. Alpha is the basis, diba? We already set this one as 0.05. So in this case, if you try to look at the value, 0.82 is greater than 0.05. So if it's greater than, so if p-value is greater than 0.05, so fail to reject. So we'll copy this and then still fail to reject the null hypothesis. So what will be the conclusion? So the conclusion is that, so we will just use the null hypothesis. So for the conclusion, we simply copy this. Okay, so at least one group has significant difference in their means. Again, we don't know which group. We don't know if it's the control group. We don't know if it's the treatment group. But we know that there is no difference. In this case, there is no difference. Ano? Fail to reject nga pala. There is no difference. Why did I copy the alternative? Here. We don't know so there is no difference. Okay? No significant difference. So you need to have this one sa Excel. This will be your answers. So every after table there should be like this. Okay, so only in histogram that we don't have we don't have any interpretation. Here we have this interpretation. Okay, let's have the next one. So next one is paired t-test. Okay, let's try paired t-test. So paired t-test is used for pre-test and post-test. So this one. So if there is before or after, so that's paired t-test. So let's use data again. Data analysis. So paired t-test is this. T-test paired to sample for means. So variable 1 would be our pre-test. It's always the before. Basta that the research is there is before or after, pre-test, post-test, that is paired t-test. And then this one. Okay, so hypothesize mean difference, of course. Our null hypothesis, there is no difference. And when we say no difference, that's 0. No difference. So label alpha is 0.05 again. So let's just click OK. So this is for paired t-test. So I'll just type here paired t. Okay. Paired t-test for pre-test and post-test. Post-test. How do you write that? I'm not sure. I'll just copy capital letters, no? Pre-test. And this one is post-test. Okay. Okay, so we have the same interpretation for, so take note for t-test, we only need to use the p-value. So I'll just copy the p-value interpretation here, this one, and then till this. So again, I'll just, this is, you don't need to write this one, this is just a guide, just in case you are going to, you don't need to copy this part, kay the interpretation will be put this portion. Okay, so let's try. So p-value, let's have the null and alternative hypothesis. So in this case, we can actually see. So there's no significant difference between the means of the groups. Okay, and then this one is there is a significant difference. So there is a significant difference. Okay, so let's copy this. So in this case, our null hypothesis, so let's just edit it according to the given. There is a significant difference between the means of pre-test and post-test. So let's just change the groups to pre-test and post-test. Okay, then this one, there's no significant difference. There is a significant difference. So it's just equals and not equal. Okay, the means are equal or not equal. So if we're talking about or dealing about equality and not equality, so that is actually two-tail. Okay, so we're going to make use of two-tail test. But if we're going to compare, which is the greater than or less than, that's one tail. But in our case, we will just use the two-tail test. The two-tail test. So our p-value would be this. Okay, so the p, then we have the t less than or equal to two-tail. So we'll just copy this one. It will be our p-value. So how do we interpret this one? This is, so we can retype this one. That's 2.44 times 10 to the power of negative 13. So it's a very, 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 very small number. It's 0.000000, so 13 times until 244. Okay, so we can actually I'll just put it here. So it means very small. But remember, our alpha value is 0.05. We set it to 0.05. So of course, the p-value is smaller than 0.05. So what will be the remarks? So our remarks, it means that it's very small. The p-value is very small. So we reject the null hypothesis. So if we reject the null hypothesis, what would be the conclusion? So the conclusion would be the alternative. So the alternative hypothesis is there is a significant difference. Okay? So that's for paired t-test. Okay, next let's have, what's the next one? Let's have the f-test for variance. So f-test for variance, we are checking if there is a difference between the variances of the two groups. In our case, the two groups available here is the control and the treatment. So we will make use of this data set again. So data analysis. So we will choose f-test to sample for variance for f-test. Okay, so variable 1 would be the control. Variable 2 would be the treatment. And then again, label. And then 0.05, that's okay. And click OK. And you will have this. So in this scenario, instead of the means, we use the variance as to compare. Okay, so if we check the value here, so we will make use of p-value gapon. So I'll just copy this one as your guide. So this will be the guide. Oops, sorry. Control C, Control V. Okay. Okay, now, instead of means, we have variance. So between variances, the groups, and there is no significant difference between the variances. Okay, so let's start with the yeah, I'll F-test. I'll just put F-test. So same, actually it's almost very similar sa paired t-test. Okay, so in this case, so again, it's variances of the control and treatment groups, diba? So we have control here, control and treatment. Groups. So I'll just copy this one. I'll just put there is a significant. Okay. Just check if it's still okay. So it's still sorry, just checking. Okay, so our p-value is, so this one 0.3855 something. I'll just copy and paste. Alpha is 0.05. So in this case, our p-value is greater than 0.05. It's greater than, so it's failed to reject. Copy this one, fail to reject. So if it's failed to reject, so as is, there is no significant difference. Okay, so that's for F-test. Okay, next, let's have t-test sample assuming equal variances. So technically, since in our F-test, it's been proven that there is no significant difference, so their variances are equal. So we can actually use t-test with equal assuming equal variance. Okay, so same, we just use this one, data analysis, then go to sample assuming equal variances. So almost similar the way we input the value. So we have variable 1, which is control, variable 2, which is treatment. Okay, so including the title, then labels, and then again 0, then okay. Okay, so this is equal. I just put equal, then t. Okay, so this is our, oh wait, I forgot to rename this one. F244 variances of control and treatment groups. For equal variance, so the same, it's of for control and treatment groups. Okay, so in this scenario, it's very similar to this. Again, we just use the p test. So equal, or the p-value, not p-test, p-value. Just copy this one, and then this one. Okay, so since it's actually the same, it's there's no significant difference and there is a significant difference. So again, we'll make use of the two-tail. So this will be our value 0.82. So 0.82 is greater than, so we fail to reject. So in this scenario, we fail to reject. Okay, fail to reject. So if it's failed to reject, there is no significant difference. I forgot to change. It should be control and treatment. Okay, next, let's say the group has you don't know the variance. It's in the F test there is a significant difference. So it means that the assumption would be an equal variance. So I'll just use the same data set. Okay, we don't have any other group, but just in case it happens, so we go to data analysis, so we can choose assuming unequal variances. So same, it's the same method. Just select this one, variable 2 with the treatment, and then labels 0, hypothesize mean is 0. Okay, so this is unequal. So almost the same. Just so I'll just copy the guide sa assuming equal, and also the guide for the interpretation here. Let's check if the interpretation are different. Let's see if different by if unequal or equal ang assumption. So actually most oftentimes dili man kaayo different. So if you see, the value is actually the same, di ba? So 0.8247. So that's why it might have a difference whenever you don't actually know the variance. But in this scenario, Manggod, we already know the variance. It's here. It's stated here. So it's 12 and then 13.96. It's not very far from one another. So that's why the conclusion is there's no significant difference. Okay, let's have the next one. Correlation and regression. So for correlation and regression, we need two columns. So let's say we want to know if there is, so we need to determine which has the effect with one another. So let's say exercise hours and exercise hours and weight. Okay, weight. So thus having more time in exercise affects weight. So in this case, the independent variable is the exercise hours because we can control, diba? Remember, the input here would be the exercise hours, and then the expected dependent variable would be weight because the weight will depend on we think that there is a relationship between our weight and exercise hours. We might think that the weight gets less if we have more time to exercise, or more weight if less time sa exercise. So let's try to see if there is a correlation. Let's check first. So to check the correlation, let's go to data analysis, then correlation. The input range would be this, weight, kilograms until exercise, all of the data. Okay, columns and labels. Okay, then let's just click OK. So we have here our correlation. So we have negative 0.98. Oh, I think it's very, very strong. Diba? Remember, we have the interpretation. there's a table. So refer na lang sa ano ha, sa slide. I will also post the slides. So remember, if it's negative 0.9 to negative 1, the negative 1, the relation is very strong. So it's because there is a dash, so I'll just put this. Okay, let's make it a string. Okay, so it means that we have a very strong relationship. But what type of relationship? This is negative, so negatively strong relationship. So when we say negatively strong, it means that one variable goes up, the other variable goes down, diba? So if the weight goes up, it means that you have less exercise, or vice versa. If the exercise hours goes up, the weight goes down. If the exercise hours goes down, the weight goes up. So that will be our R. Okay, I'll just put capital R lang. R is this. Okay, so what will be the interpretation or the remark? So this is strongly negative relations, strong negative correlation. And so what would be the conclusion? Conclusion, so if exercise hours increases, just like there's a strong indication Okay, so that will be our conclusion. So we can now proceed to regression. Okay, so go back again to data set. So I'll just rename this one as correlation. So for regression, so same, we just use the same data. Let's go to data and then data analysis, then we have regression. Okay, so input y, so what will be our dependent variable? It would be the weight, diba? Dependent, that depends on the exercise, so our x would be the exercise hours. Okay, and then labels, let's put confidence level is 95%. Just don't check the constant is 0 because we don't know. Okay, then that's all. Okay, so this will be the values. So what we need is the significance F and F, and we also need the p-value. But in our case, we just need to know, we will use p-value lang. We will not use the f-value na lang, ha? So, the same interpretation, we will make use of this p-value. Okay, so here, p-value alpha and then remarks. Okay, p-value alpha. for the null hypothesis, we will just say that there is no significant correlation. Because again, the initial is correlation and the basis of regression is correlation. No correlation between weight and exercise hours. This one also, there is a significant. So in this case, our p-value is no, we don't need to use the p-value. Sorry, we don't need to use the p-value here because this is regression. Never mind. Okay, never mind. So we're going to use the r. Okay, instead of the p, we use the r squared value. Asama to r squared. Here, it's r squared. Sorry, this is r squared. So our r square is 0.97, and remember there is a table for this one. So the table will give us, so what will be the remark? This is excellent fit, diba? The model is excellent fit. Excellent model fit. So we can also create the model, which when I say model, that's the equation. Insert. I'll insert here. Okay, so what is the model? When I say model, it's the linear regression equation. So we have y equals, so your exercise hours will be the slope, this one. So we'll just type 1 point, so round off to 2 decimal places, and then we have our x, okay, plus our intercept. So intercept is this 81.80. So we have 81.80. Okay, so we'll just put the labels here where, so ang butang where x is exercise hours, and I'll just put y is weight in kilograms. So again, this will be the model, the equation. Okay, so since excellent model fits here, it means that the model, the line, can actually predict. So conclusion, so there is a strong, or excellent, not strong, excellent regression fit between exercise hours and weight in kg. Okay, so we can actually see also, we can create the what they call this, the graph. Just see regression here. So if we go back to data set, we select this, we can create the graph here. So insert, where is this? Scatter. Let's try to use scatter. So this is the graph. Okay, so I'll just transfer it to here. So as you can see, there is almost a line. If we try to put the line here, so if I go to chart design, quick layout. I'll use this one, layout number 9. We can see that there is this. Sorry. It should be, wait muna. It should be opposite. Mag-on na si ano. I'll just change the arrangement because for the graph it's always the x value ang una. Our x value here, our independent is exercise R's man. So insert. Okay, there. Quick layout. There. Okay, so almost the same na ano. So I'll have here. So again, when you do regression, the first column should be the x value. You do the scatter plot. So this is the equation. If you try to check, that is our model. Negative 1.90x plus 81.80. It's here. Our r squared is 0.97. It's here. Okay, so this will be the scatter plot for weight in kilograms and exercise R. So take note, the horizontal axis is the x value, while the vertical axis is your weight, your y value. Just put it here. Just put the label nila para ano, legends. Let's go. Right there. Okay, maano. Okay, so we're done. We're done with the graph. So this will be your activity would be similar to this one. So I'll just save this one. LW7 sample. Okay, I will upload this one for you to follow. Okay, so that's all for today. Wait, yeah, okay. So that's all for today. See you in our lecture meeting. Bye-bye. Bye-bye. Bye-bye.